Alright, so today's day 5 of the April lead coding challenge. The question today is best time to buy and sell stock too. We have an array representing the stock price at day I. So we are only looking at one stock, and basically we're looking at the back history and try to reasoning how much money we could make if we just time the market perfect every time. Is the maximum profit we can make with this particular stock. We need to design an algorithm to do so, and we can complete as many transactions as we like. We can buy one share of the stock, or buy and sell one share of the stock multiple times. So the only transaction we can do is either buy a share or sell a share. And the other requirement is that we may not engage in multiple transactions at the same time, which means you must sell the stock before you can buy again. So just looking at the days, if we have n days, at any given day we can only have two possible states. So one is that we hold one share or we don't hold any share. So that's the only possible situation, two states per day, so that we can satisfy this criteria. The example here we have 715364. So if we only make one transaction, we can buy at 1 and sell at 6. The maximum profit by doing that bigger transaction, longer transaction is 5. But we can do multiple transactions. So we can do 2 here, buy 1 and sell at 5, locking profit of 4. Buy at 3 and sell at 6, locking another profit of 3. The 3 plus 4 is the 7. That's the total most optimal profit we can do. So just look at because these two things and this little two transactions actually cover the same length as the bigger one. We see that if we just buy and sell at each endpoint, we get a profit of 5. But if we do two multiple transactions, smaller transactions, we'll get 7. The difference is 2, which is actually equal to the dip here. So this tells us if we, whenever we see that we can make an immediate profit, we always opt for that, because if we have a dip in later on, we don't want to lose that profit. So whenever we see we can have an immediate profit, we always lock in that. So that's what this example is telling us. The second one here we have 1, 2, 3, 4, 5, and the things that we don't have any transaction fee, we could either just do one giant bigger transaction, buy at 1 and sell at 5. We got this optimal 4, which is the explanation here. But we can also buy at 1, sell at 2, buy at 2, sell at 3, and just do 1, 2, 3, 4 different smaller transactions in sequence. So we don't violate this multiple transaction criteria. And since there are no transaction fee, we can make 1, 2, 3, 4 little transactions to also get the profit of 4. And in the very end, last example, we have a monotonically decreasing sequence. There is no way we can make any money whatsoever, so we return a default 0. So the solution is pretty straightforward. Just try to lock in smaller profit whenever we can. So we just iterate over the price once, looking at the two adjacent price. If there is some money we can make, we just grab that. Otherwise, we just move forward. So that's pretty much the strategy. Let's code it up. So I guess we need to it doesn't tell us the price. So as usual for the Leetcode problem, always try to code edge case handling if possible. So if there's if we don't get any input, we just return 0. No history, no money. So if the next day's price is higher than today's, what we would do is to lock in that profit. And that's all. That's all this question is about. So the time complexity is linear, order of n, and the space complexity is constant. All we have is pointers. So yeah, that should be wrong answer. -3. What do we have? Oh, sorry. Okay, that's yeah. This is the code for this question. I think you can actually, if you using some Python, you can actually reduce this to one-liner, but it doesn't matter.